Hello everyone, welcome to my channel. This is Leo. Let's do some more Leetcode problems today. So today's problem is called longest common subsequence. This is a very typical dynamic programming problem. So let's solve it together. We were given two strings, text1, text2. We're going to return the length of their longest common subsequence. If there's no such thing, we'll return 0. A subsequence is a string that is new string generated from the original string with some characters deleted without changing its relative order. So it is different from substring because substring is a consecutive part of a string, but the subsequence is just some random characters from here. But this relative order will remain the same. Okay, like we say, ACE is a subsequence of ABCDE. And we can also say that ABE is another substring. Or we can say ABDE, anything you like, but just remain the relative order of the characters. Okay, so in the first example, ABCDE and ACE have a longest common subsequence of 3, which is A, C, and E. All right, so how do we approach this problem? So intuitively, we can think of it as generating all the subsequences from text1 and text2, put them in a list, and compare. If they have the same, we can increment the longest common subsequence number. Okay, but that will result in very bad time complexity. So can we do better? Yes, of course. We can use dynamic programming to compare each character based on previous result. For example, if we compare A and A, the longest, since they're the same character, the longest common subsequence now would be 1. And we'll take a look at the next position, which is B and C. Okay, since they're not the same, our LCS remain the same. Okay, and now we can start looking at A, B, C, and AC, or we can look at AB or ACE. So whatever you choose, because we're including all the possibilities within this DP table. Okay, actually, let me show it to you. Okay, so in case we have some empty strings, we'll include that in our DP table. And we have A, C, and E. Okay. Next, we'll have A, B, C, D, E. Okay, so empty string and empty string that have no longest common subsequence, we'll just put a 0 here, and everything that goes with an empty string will result in a 0 longest common subsequence. Also, here we're comparing a string with an empty string, so everything should be 0 here. Okay, and now we come to the first character of each string. A and A, they're the same. So we can just put 1 here because this is the first character we're comparing with. And second, we move here. What are we comparing? We're actually comparing A, as shown here, with AC in the second string. Okay? So C and A, are they the same character? Of course not. So we either decrement C to compare A and A, that is the longest common substring so far, or we decrement A, which is here. Decrement A results in an empty string compared with AC. We will have the maximum of these two values. Okay. So that's going to be 1. And also that works for E and A at the same time. Okay, that will result in 1 as well. Okay. And next, of course, A and B are not the same. We have to look at this one and this one, and get the maximum would be 1. B, C not the same, C, E not the same, okay? And here we have A, C not the same, and here we got the problem. C and C are the same. So how do we compare? We have to subtract C from both strings and add 1 based on that, okay? So now where are we looking? We're looking at this part. This is the longest common subsequence without the common character here, okay? So we have to get our decision based on that result. That results in 2, okay? Now, if we compare ABC with ACE, which is where we're standing, the longest common subsequence would change. Because C and E are not the same, we're looking at here and get the maximum. So we have a 2 right here, okay? And next, A and D not the same. Not the same, we look up and look left. Now we get the maximum, which is 1, and C and D, it's different. And now it's different, 2, okay? And here, A and E are not the same. Get the maximum. C and E are not the same, get the maximum, and E and E are the same. So we're not looking up or left, we're looking up and left. And since they're the same, we add 1 toward this, okay? And our final result will be saved in the last cell, okay? So now we can code it out. Let's make M the length of the first text, N equals to the second text, and we'll initialize our DP table with M plus 1, M plus 1, okay? So initially, everything was set to 0, so we don't have to worry about this 0 row and this 0 column. And we're gonna iterate from the first character from here, okay? But this starts from 1, and in our string it starts from 0. So we have to compare if text1 dot character at I minus 1 equals to text2 dot character at j minus 1. Okay, if they're the same, our DP table will be based on the result of DP I minus 1 and j minus 1. Okay, else, if they're not the same, our DP result will be based on the maximum of subtracting 1 from text 1 or subtracting 1 character from text 2. Okay, and our final result will be returned in the last cell, which is here. Okay, let's run it out. Yeah, I think that is acceptable. So the complexities, we're doing some for loops here, okay? So it's just mn, and for the space complexity, it will just be mn because we're adding a DP table here. All right, thank you very much, and I'll see you in our next video.